Imagine a world where rivers of methane carve through icy landscapes, and lakes shimmer under a hazy, golden sky. This isn't a scene from a science fiction novel. It's Titan, Saturn's largest moon. Picture Earth, but with a twist of the alien, where rain falls as liquid methane and dunes of ice stretch as far as the eye can see. Titan is a place that challenges our understanding of what a world can be, a place that beckons us to explore its mysteries. Join us as we dive into the enigmatic landscapes of Titan, a moon that's both eerily familiar and undeniably strange. This is a journey to a world that could hold the secrets of life beyond Earth, and it starts right here, right now. The enigmatic Titan, a world apart. Titan, the largest moon of Saturn, is a world that defies easy comparison to anything in our solar system. It's a place where rivers run, but not with water. Instead, they flow with methane and ethane, carving channels into the icy surface much like rivers on Earth. Lakes and seas dot the landscape, their shores lapping with hydrocarbons rather than liquid water. This alien world, shrouded in a thick, hazy atmosphere, presents a landscape both familiar and utterly foreign. The surface of Titan is a chilly minus 290 degrees Fahrenheit, minus 179 degrees Celsius, making it far too cold for liquid water. Yet, it's not a barren wasteland. Sunlight interacts with the methane in Titan's atmosphere, creating a complex chemistry that leads to the formation of lakes and rivers. These features are reminiscent of Earth's water bodies, but with a crucial difference. They're filled with hydrocarbons. The largest of these, Kraken Mare, is bigger than the Caspian Sea on Earth. It's a vast expanse of liquid that reflects the dim sunlight, offering a glimpse into the moon's unique hydrological cycle. Titan's landscape is also shaped by winds, which blow across the surface, creating dunes that stretch for miles. These dunes, made of tiny particles of organic material, are reminiscent of sand dunes on Earth, but they're not made of silica. Instead, they're composed of hydrocarbons, adding to the moon's otherworldly allure. The winds also play a role in shaping the lakes and rivers, carving out channels and depositing sediments in patterns that are eerily familiar to those seen on our own planet. Exploring Titan is like stepping into an alien world that's eerily similar to Earth, yet utterly different. It's a place where the familiar is twisted into the unfamiliar, where lakes and rivers flow with hydrocarbons, and where dunes stretch across the landscape, shaped by winds that howl through a thick, hazy atmosphere. It's a world that challenges our understanding of what a planet, or a moon, can be, offering a glimpse into the incredible diversity of our solar system. Saturn's largest moon, a mysterious giant. Titan, the largest moon of Saturn, is a world that feels both familiar and utterly alien. It's a place where rivers carve valleys, lakes dot the landscape, and dunes ripple across the surface, much like Earth. Yet, these features are not shaped by water as we know it, but by methane and ethane, which exist in liquid form in Titan's frigid environment. The lakes, for instance, are filled with these hydrocarbons, and they can be as large as the Great Lakes in the United States. The rivers, too, are fed by methane rain, creating a landscape that mirrors Earth's hydrological cycle, but with a twist that's uniquely Titan. The surface of Titan is a tapestry of diverse landscapes. There are vast dune fields, likely composed of organic materials, that stretch across the moon's equatorial regions. These dunes are reminiscent of those found in Earth's deserts, but they're not made of sand. Instead, they're likely composed of tiny particles of organic material that have settled out of Titan's atmosphere. In contrast, the polar regions are dotted with lakes and seas, some of which are as large as several of Earth's largest lakes combined. These bodies of liquid are surrounded by what appear to be wet, bog-like areas, hinting at complex interactions between the surface and the atmosphere. Beneath its thick, hazy atmosphere, Titan hides a complex geological history. Mountains rise up, their peaks shrouded in the orange haze that permeates the moon's sky. These mountains are likely made of water ice, which, in Titan's frigid temperatures, behaves like rock does on Earth. Craters pockmark the surface, evidence of a history of impacts. Yet, many of these craters appear to be filled in or modified, suggesting that geological processes are at work, reshaping the landscape over time. Cryovolcanoes, which erupt a mix of water ice and ammonia, may also to the surface, adding to the moon's dynamic nature. Titan's atmosphere is a thick, orange haze that obscures the surface from view. It's composed primarily of nitrogen, with a smoggy mix of hydrocarbons that give the moon its distinctive color. This atmosphere is remarkably Earth-like in some ways, with a similar surface pressure and a cycle of precipitation and evaporation. Yet, instead of water, methane plays the leading role. Methane clouds form and rain down, carving rivers and filling lakes. This cycle is a testament to the moon's active weather systems, which are driven by the same principles that govern Earth's weather, but with a unique Titan twist. The atmosphere also hosts complex organic chemistry, with sunlight breaking apart methane molecules and allowing them to reform into more complex hydrocarbons. This process is thought to be similar to the chemistry that might have led to the origin of life on Earth, making Titan a fascinating place to study. A veil of mystery, Titan's thick atmosphere. Titan, Saturn's largest moon, is a world shrouded in a thick, hazy atmosphere, making it one of the most enigmatic bodies in our solar system. This atmosphere, primarily composed of nitrogen with a smattering of methane and other hydrocarbons, is even denser than Earth's, creating a perpetual veil that obscures the surface from prying eyes. The haze is so thick that it scatters visible light, making it difficult for even our most advanced telescopes to pierce through. It's like trying to look through a thick fog on a San Francisco morning, but on a much grander scale. The atmosphere's composition is eerily reminiscent of Earth's primordial atmosphere, but with a twist. Instead of water, Titan has methane and ethane, which cycle through the moon's environment in a process analogous to Earth's water cycle. Methane evaporates from the surface, forms clouds, and then rains back down, carving rivers and filling lakes. The lakes, filled with liquid methane and ethane, are scattered across the polar regions, much like the Great Lakes on Earth. However, unlike Earth's lakes, these are filled with hydrocarbons that would be highly flammable in our oxygen-rich atmosphere. The landscape is a surreal mix of Earth-like features and alien chemistry, creating a world that is both familiar and utterly foreign. Beneath the hazy veil, the surface is a complex tapestry of dunes, mountains, and lakes. The dunes, composed of tiny hydrocarbon particles, stretch across vast plains, similar to the sand dunes in the Sahara. Yet, instead of silicon-based sand, these dunes are made of organic compounds that rain down from the atmosphere. The mountains, likely made of water ice, rise above the plains, their peaks shrouded in the perpetual haze. The rivers and lakes, filled with liquid methane, wind their way through the landscape, creating a network of waterways that would be instantly recognizable to any Earth-based explorer. It's a world that invites comparison to Earth, yet constantly reminds us of its alien nature. The atmosphere also plays a crucial role in protecting the surface from harmful radiation. Much like Earth's ozone layer, Titan's thick atmosphere acts as a shield, absorbing high-energy particles from the Sun and Saturn's magnetosphere. This protective veil allows for the possibility of more complex chemistry on the surface, potentially even the formation of prebiotic compounds. The atmosphere's density and composition create a greenhouse effect, trapping heat and making the surface warmer than it would be otherwise. Despite the extreme cold, the surface temperature is a balmy minus 179 degrees Celsius, which is downright toasty compared to the frigid minus 218 degrees Celsius of nearby space. This relative warmth allows for the existence of liquid hydrocarbons, creating a dynamic and active environment. The haze, a shield of secrets. Titan, Saturn's largest moon, is a world of enigmas, and its thick, hazy atmosphere is one of the most intriguing. This orange-brown shroud, composed primarily of nitrogen and hydrocarbons like methane and ethane, is a stark contrast to Earth's clear skies. It's a shield, yes, but one that conceals a wealth of secrets, much like the dense fog that rolls in over San Francisco Bay, obscuring the city's iconic landmarks until it lifts. This haze is not merely a veil. It's a dynamic, ever-changing layer that plays a crucial role in Titan's unique environment. The haze is created by a complex process involving ultraviolet light from the sun. This light breaks down methane and nitrogen in Titan's upper atmosphere, leading to the formation of a variety of organic molecules. These molecules then combine to form tiny particles, which scatter sunlight and give the moon its characteristic hazy appearance. It's a bit like the smog that can form in Earth's cities, but on a much larger scale and with a different chemical composition. The haze is so thick that it's difficult to see through it, even with powerful telescopes. This makes Titan's surface a mystery, a landscape waiting to be explored and understood. Yet, this haze is not just a barrier, it's also a protector. It shields Titan's surface from harmful solar radiation, much like Earth's ozone layer. This protection is vital, as it allows complex organic molecules to form and accumulate on the surface. These molecules are the building blocks of life as we know it, and their presence on Titan makes it one of the most promising places in our solar system to search for extraterrestrial life. The haze also plays a role in Titan's unique weather patterns, creating a cycle of methane rain and evaporation that's eerily similar to Earth's water cycle. It's a testament to the complexity and diversity of our universe, a reminder that even in the cold, distant reaches of our solar system, there are worlds that echo the familiar. Beneath the haze, Titan's surface is a landscape straight out of a science fiction novel. There are lakes and rivers of liquid methane and ethane. Their surface is calm and mirror-like, reflecting the dim light that filters through the haze. These bodies of liquid are scattered across the moon's surface, much like lakes and seas on Earth. There are also vast dunes of organic sand, stretching for hundreds of kilometers. These dunes are formed by winds that blow across Titan's surface, carrying tiny particles of organic material and depositing them in great piles. It's a landscape that's both alien and familiar, a testament to the power of nature to create beauty and complexity, even in the most unlikely of places. A glimpse through the haze, Cassini-Huygens mission. Titan, Saturn's largest moon, is a world shrouded in a thick, orange haze, hiding a landscape both alien and eerily familiar. Beneath the clouds, rivers carve their paths through valleys, and lakes glisten under a dim, sunless sky. The Cassini-Huygens mission, a joint endeavor by NASA, the European Space Agency, and the Italian Space Agency, has been our window into this enigmatic world. Launched with the purpose of studying Saturn and its moons, Cassini carried the Huygens probe, designed to descend through Titan's atmosphere and reveal its surface secrets. Cassini's radar and imaging systems have painted a picture of Titan that is both strange and reminiscent of Earth. Rivers of liquid methane and ethane snake across the landscape, feeding into vast lakes and seas. These hydrocarbons, which would be gases on Earth, flow freely on Titan's frigid surface, where temperatures plunge to around -290 degrees Fahrenheit, -179 degrees Celsius. The largest of these bodies of liquid is Kraken Mare, a sea larger than the Caspian. It's a world where geology is driven not by water, but by these exotic chemicals, creating a landscape that is both alien and hauntingly familiar. The Huygens probe, after a 7-year journey, plunged through Titan's atmosphere in 2005, providing the first ever close-up images of its surface. It revealed a world that, in some ways, mirrors our own. Channels and valleys, likely carved by flowing methane, stretch across the landscape, reminiscent of dry riverbeds on Earth. Huygens even captured images of what appeared to be drainage channels leading to a shoreline, suggesting a complex hydrological cycle. The probe's instruments detected the presence of methane and ethane, confirming the existence of a dynamic, Earth-like, albeit much colder, environment. Cassini's mission has also uncovered evidence of cryovolcanoes, mountains that erupt not with molten rock, but with water ice and ammonia. These features hint at a geologically active world, where internal heat drives processes similar to those that shape Earth's surface. The moon's thick atmosphere, rich in nitrogen and hydrocarbons, creates a hazy, orange sky, scattering sunlight in a way that gives the surface a dim, diffused light. It's a world where the sun is a mere pinprick in the sky, providing little warmth but casting long, dramatic shadows. Titan's landscape is a testament to the diversity of planetary processes, offering a glimpse into the potential for exotic life forms to exist in the cold, distant reaches of our solar system. The first close encounter, Voyager's discovery. In the frigid expanse of the outer solar system, Saturn's moon Titan stands as a world of enigmatic beauty and alien landscapes. It's a place where rivers run, but not with water. Methane and ethane carve channels into the icy surface, creating a network reminiscent of Earth's own waterways. Lakes and seas dot the landscape, their shores lapping with hydrocarbons instead of liquid water. The skies are a hazy orange, shrouded in a thick atmosphere, the only moon in our solar system to boast such a feature. This atmosphere, rich in nitrogen, creates a pressure similar to Earth's, making Titan a world that, in some ways, feels eerily familiar. The first close encounter with this alien world came courtesy of the Voyager spacecraft. As it whizzed by, Voyager's instruments pierced the thick haze, revealing a surface both alien and strangely Earth-like. The images sent back showed a world veiled in secrecy, its details obscured by the dense atmosphere. Yet, even through the haze, scientists could discern a complex landscape with what appeared to be vast plains, towering mountains, and even hints of liquid on the surface. It was a tantalizing glimpse, a promise of a world waiting to be explored in greater detail. Titan's rivers and lakes, though composed of different substances, mirror the hydrological cycles found on Earth. Methane and ethane evaporate from the lakes, forming clouds that eventually precipitate back onto the surface, carving rivers and filling lakes in a cycle that echoes our own water cycle. The lakes, particularly those found in the polar regions, are reminiscent of Earth's own Arctic and Antarctic lakes, their shapes and sizes varying greatly. Some are vast, stretching hundreds of kilometers, while others are small, barely discernible from the surrounding terrain. The largest of these, Kraken Mare, is comparable in size to the Caspian Sea, a testament to the scale of Titan's geological features. The mountains of Titan, while not as towering as those on Earth, are no less impressive. They rise from the plains, their peaks shrouded in the perpetual haze. These mountains are likely composed of water ice, which, in Titan's frigid temperatures, behaves like rock. The rivers and lakes have carved valleys and canyons into these icy mountains, creating a landscape that is both alien and familiar. The similarities to Earth's own mountainous regions are striking, yet the differences serve as a reminder of the vast gulf that separates our worlds. Titan's unique atmosphere, a nitrogen-rich enigma. Titan, Saturn's largest moon, is a world that feels eerily familiar yet undeniably alien. Its atmosphere, a thick, hazy blanket, is composed primarily of nitrogen, much like Earth's. However, the similarities end there. The air is also rich in methane and other hydrocarbons, giving Titan a distinctly alien character. This nitrogen-rich atmosphere is 4 times denser than Earth's, creating a surface pressure similar to what we experience at the bottom of a swimming pool. The haze, a photochemical smog, scatters sunlight in a way that makes the sky appear hazy and orange, much like a perpetual sunset on Earth. The methane in Titan's atmosphere plays a crucial role in its weather and surface features. On Earth, water cycles through evaporation, condensation, and precipitation. Titan has a similar cycle, but with methane instead of water. Methane evaporates from the moon's lakes and rivers, condenses in the atmosphere, and falls back to the surface as rain. This creates a landscape dotted with lakes, rivers, and even dunes, but instead of water, they are filled with liquid methane and ethane. The largest of these lakes, Kraken Mare, is larger than Earth's Caspian Sea. The rivers carve their paths through the landscape, much like the Mississippi or the Amazon, but their banks are made of ice, not soil. The temperature on Titan is a frigid minus 290 degrees Fahrenheit, minus 179 degrees Celsius, making it far too cold for liquid water. Instead, water ice is as hard as rock, and methane and ethane flow like water does on Earth. This creates a landscape that is both familiar and alien. The dunes, for instance, are made of organic materials that rain down from the atmosphere, similar to how dust settles on Earth. However, these dunes are not made of silica like Earth's, but of hydrocarbons, giving them a unique composition. The winds on Titan, while gentle, are enough to shape these dunes and create ripples that resemble those found in deserts on Earth. The atmosphere also plays a role in Titan's unique weather patterns. While Earth experiences hurricanes and thunderstorms, Titan has its own set of meteorological phenomena. For instance, the Moon experiences polar clouds and storms, much like Earth's polar vortices. However, these storms are driven by methane, not water vapor. The clouds can grow to enormous sizes, covering vast areas of the Moon's surface. The winds within these storms can reach speeds of up to 45 miles per hour, 72 kilometers per hour, creating waves and ripples on the methane lakes. Despite the cold, Titan's atmosphere is dynamic and ever-changing, much like Earth's, but with a distinctly alien twist. The dance of molecules, organic chemistry in the air. Titan, Saturn's largest moon, is a world that feels eerily familiar yet undeniably alien. Its landscape is a patchwork of dunes, mountains, and vast plains, all bathed in a perpetual orange haze. Rivers and lakes, not of water but of methane and ethane, carve their way through the terrain, creating a scene reminiscent of Earth's Arctic regions, but with a twist that's purely extraterrestrial. The air is thick with a rich brew of organic molecules, making Titan a fascinating subject for scientists studying the chemistry of life's building blocks. The atmosphere of Titan is a dynamic dance of molecules, a complex interplay of organic chemistry that's unlike anything found on Earth. Nitrogen makes up the bulk of the air, much like our own planet, but the similarities end there. Titan's atmosphere is also rich in hydrocarbons, such as methane and ethane, which form clouds and precipitate as rain. These hydrocarbons undergo a variety of chemical reactions, driven by sunlight and cosmic rays, creating a smorgasbord of organic molecules. It's a bit like a giant, alien chemistry set, with reactions happening constantly, creating new molecules and breaking down old ones. One of the most intriguing aspects of Titan's atmosphere is the presence of tholins, complex organic molecules that form when simpler hydrocarbons are exposed to ultraviolet light. These tholins are thought to be responsible for the Moon's characteristic orange hue. They're also a key part of the dance of molecules in Titan's air, acting as catalysts for further chemical reactions. On Earth, tholins are found in certain extreme environments, like the depths of the ocean, but on Titan, they're a major player in the atmospheric chemistry. They're a reminder that, while Titan might seem alien, it's not so different from Earth in its fundamental chemistry. The lakes and rivers of Titan add another layer to this complex chemical dance. These bodies of liquid hydrocarbons are not just passive features of the landscape, they're active participants in the Moon's chemistry. They evaporate, forming clouds that rain back down, and they interact with the solid surface, dissolving minerals and carrying them away. It's a cycle that's familiar to us on Earth, but with a twist that's uniquely Titan. The result is a landscape that's constantly changing, shaped by the dance of molecules in the air and on the ground. It's a world that's both alien and eerily familiar, a testament to the power of chemistry to create diverse and dynamic environments. A cold, alien world, Titan's frigid temperatures. Titan, the largest moon of Saturn, is a world that defies earthly comparisons. Its surface is a chilly minus 179 degrees Celsius minus 290 degrees Fahrenheit, making it one of the coldest places in our solar system. This extreme cold is not just a number, it's a defining characteristic that shapes Titan's landscape and atmosphere. Methane and ethane, which would be gases on Earth, freeze into icy solids here. These hydrocarbons play a role similar to water on Earth, carving rivers, filling lakes, and even creating rain. Picture a world where, instead of water, liquid methane flows through channels and pools in vast depressions, much like the Great Lakes on Earth. The frigid temperatures on Titan also mean that its atmosphere is a thick, hazy soup of nitrogen and hydrocarbons. This atmosphere is so dense that it's even thicker than Earth's, creating a surface pressure about 50% greater than what we experience. It's like being at the bottom of a swimming pool, but instead of water, you're surrounded by a cold, alien atmosphere. The haze is so thick that it scatters sunlight, making the surface dim and orange. It's a perpetual twilight, a far cry from Earth's bright days and dark nights. Despite the cold, Titan is far from a dead world. Its surface is dynamic, with winds blowing at speeds up to 1,300 kilometers per hour, 800 miles per hour. In its upper atmosphere, shaping dunes and moving sediments. These winds are driven by the same forces that create weather on Earth, but the results are uniquely Titanian. The dunes, for instance, are not made of sand but of tiny particles of organic material, possibly similar to coffee grounds in texture. They stretch for hundreds of kilometers, reminiscent of the vast sand seas on Earth, but their composition and formation processes are entirely alien. The cold also means that Titan's surface is incredibly quiet. Sound doesn't travel well in such frigid temperatures, and the lack of liquid water means there are no waves or tides to create noise. It's a silent world, where the only sounds might be the whisper of winds or the distant rumble of methane rain. It's a stark contrast to Earth, where life and weather create a symphony of sounds. Yet, this silence is a reminder of the harsh, alien nature of Titan. It's a world that challenges our understanding of what a planetary surface can be, pushing the boundaries of our exploration and imagination. The cryovolcanoes, ice mountains of fire. Titan, Saturn's largest moon, is a world of icy mysteries, where lakes and rivers flow not with water, but with hydrocarbons like methane and ethane. Beneath its thick, hazy atmosphere, a landscape both familiar and alien stretches out, dotted with features that echo Earth's geology, yet are fundamentally different. Among these are the cryovolcanoes, mountains of ice that erupt not with molten rock, but with a frothy, watery slush. These icy volcanoes are a testament to the dynamic and active nature of Titan's geology, offering a glimpse into the moon's complex internal processes. Picture a landscape where mountains rise not from the slow upheaval of tectonic plates, but from the gradual accumulation of icy lava flows. These cryovolcanoes, also known as ice volcanoes, are thought to form when subsurface reservoirs of liquid water, kept warm by Titan's internal heat, erupt through the moon's icy crust. As the water erupts, it quickly freezes, creating a distinctive, icy landscape. The result is a terrain that might remind you of Earth's volcanic regions, but with a twist of frost. Instead of the black, basaltic lava flows of Hawaii, or the steep stratovolcanoes of the Pacific Northwest, Titan's cryovolcanoes are likely to be broad, gentle domes, their slopes smoothed by the flow of icy lava. The evidence for cryovolcanoes on Titan comes from a variety of sources. Cassini, the spacecraft that spent over a decade studying Saturn and its moons, provided tantalizing hints of these icy volcanoes. Its radar and imaging instruments revealed features that resemble volcanic constructs, such as domes, flows, and even possible calderas. One of the most promising candidates is a feature called Sotra Facula, a bright, raised feature with a central depression that bears a striking resemblance to Earth's volcanic peaks. The presence of ammonia in some of these features also supports the cryovolcano hypothesis, as ammonia acts as an antifreeze, allowing water to remain liquid at lower temperatures. Understanding these cryovolcanoes is not just about mapping Titan's surface, it's about unraveling the moon's complex geology and potentially even its habitability. The water and ammonia erupted by these volcanoes could create pockets of liquid water beneath the surface, providing a potential habitat for life. Moreover, the study of cryovolcanoes on Titan can offer insights into the geology of other icy worlds, from Europa to Enceladus. As we continue to explore Titan, these icy mountains of fire will undoubtedly play a crucial role in our understanding of this enigmatic moon. Lakes and rivers, a familiar yet alien landscape. Titan, Saturn's largest moon, is a world that seems both eerily familiar and utterly alien. Its surface is dotted with lakes and rivers, much like Earth, but these bodies of water are not filled with liquid water, but with hydrocarbons, primarily methane and ethane. These lakes and rivers carve intricate patterns into Titan's surface, creating a landscape that is reminiscent of Earth's polar regions, yet utterly foreign. The largest lakes, such as Kraken Mare, stretch across hundreds of miles, while smaller lakes and rivers wind their way through the moon's icy terrain. The lakes are remarkably deep, with some reaching depths of up to 500 meters, and they are surrounded by shorelines that shift and change over time, much like Earth's coastlines. The rivers on Titan are fed by methane rain, which falls from the moon's thick, hazy atmosphere. These rivers can be wide and slow-moving, or narrow and swift, depending on the terrain and the volume of liquid they carry. They meander across the landscape, cutting through valleys and plains and emptying into the larger lakes. The patterns they create are strikingly similar to those seen on Earth, with braided channels, oxbow lakes, and deltas forming in much the same way. Yet, the materials involved are vastly different. On Earth, rivers are shaped by water and sediment, while on Titan, it is methane and ice that sculpt the landscape. The lakes and rivers of Titan are not static features. They are part of a dynamic and active hydrological cycle that is driven by the moon's unique environment. Methane evaporates from the lakes, forms clouds, and then falls back to the surface as rain, replenishing the rivers and lakes. This cycle is similar to Earth's water cycle, but with a crucial difference. On Titan, it is methane that plays the role of water. The temperatures on Titan are so cold that water ice is as hard as rock, and methane is the only substance that can exist in liquid form on the surface. This makes Titan's lakes and rivers a truly alien phenomenon, even if they bear a passing resemblance to those on Earth. Exploring Titan's lakes and rivers is a challenge that future missions hope to tackle. The thick, hazy atmosphere and the extreme cold make it difficult to study the moon's surface in detail. However, the data collected so far, particularly from the Cassini-Huygens mission, has provided valuable insights into this enigmatic world. The lakes and rivers of Titan offer a unique opportunity to study a hydrological cycle based on hydrocarbons rather than water, shedding light on the processes that shape planetary surfaces and the potential for exotic forms of life. As our understanding of Titan grows, so too does our appreciation for the diversity and complexity of the solar system's many worlds. The methane cycle, a strange hydrological system. Beneath the hazy, orange skies of Titan, Saturn's largest moon, a world of alien landscapes unfolds. Rivers carve their paths through icy plains, feeding into vast lakes and seas. But this isn't water flowing through these channels. It's methane, a simple organic compound that, on Earth, we associate with natural gas. Titan's methane cycle is a strange hydrological system, a dance of evaporation, condensation, and precipitation that mirrors Earth's water cycle, but with a twist that's uniquely alien. Picture Earth's hydrological cycle, but replace water with methane, and temperatures around -290 degrees Fahrenheit, -179 degrees Celsius. On Titan, methane exists as a liquid, just as water does on Earth. It evaporates from the lakes and seas, forming clouds that drift across the moon's sky. When conditions are right, these clouds release their methane as rain, soaking the icy terrain. The rainwater carves rivers and streams, cutting through the landscape and feeding back into the lakes and seas, completing the cycle. It's a familiar pattern, yet utterly foreign in its composition and scale. The lakes and seas of Titan are scattered across its polar regions, with the majority found in the north. These bodies of liquid methane and ethane are surrounded by icy shores, with some even featuring small islands. The largest known body of liquid on Titan is Kraken Mare, a sea that spans roughly 680 miles, 100 kilometers, in length. To put that into perspective, it's larger than Earth's Caspian Sea, the world's largest inland body of water. The rivers and streams that feed these lakes and seas can stretch for hundreds of miles, with some even featuring deltas where they meet the larger bodies of liquid. Titan's methane cycle is a dynamic system, with seasonal changes driving its patterns. As the moon orbits Saturn, its tilt exposes different parts of the surface to sunlight, causing the methane clouds to form and dissipate in a cycle that mirrors Earth's seasons. However, Titan's year is much longer than Earth's, with each season lasting around 7 Earth years. This means that the methane cycle on Titan is a slow, steady process, with changes occurring over long periods. Despite this, the cycle is active and ongoing, shaping the moon's surface and creating a world that's both familiar and alien in its complexity. The Northern Lakes, a mysterious network. Beneath the hazy, orange skies of Titan, Saturn's largest moon, lies a landscape that would seem eerily familiar yet undeniably alien to any Earthling. The northern region of this icy world is a labyrinth of lakes and rivers, a network that stretches across the surface like a spider's web. These bodies of liquid are not filled with water, but with hydrocarbons, primarily methane and ethane, which exist in their liquid state due to Titan's extremely low temperatures. The largest of these northern lakes, Kraken Mare, is estimated to be larger than the Caspian Sea on Earth, making it a significant feature on Titan's surface. The lakes and rivers of Titan's north are fed by a complex system of channels and tributaries, reminiscent of Earth's river systems. However, unlike Earth's water-based hydrology, Titan's methane-based cycle involves precipitation, evaporation, and collection in lakes, much like our own water cycle. The lakes vary in size and shape, with some appearing smooth and calm, while others have jagged coastlines and islands, hinting at a dynamic and active landscape. The rivers that connect these lakes can be wide and meandering, or narrow and winding, creating an intricate network that is both beautiful and mysterious. One of the most intriguing aspects of Titan's northern lakes is their changing nature. Seasonal changes on Titan, which last about 7 Earth years each, cause the lakes to expand and contract, with some even disappearing and reappearing in different locations. This dynamic behavior suggests that the lakes are not just static bodies of liquid, but are actively shaped by Titan's weather and climate. The lakes also exhibit a range of colors, from dark and smooth to specular and reflective, indicating variations in their composition and depth. These changes make Titan's northern lakes a fascinating subject for study, offering insights into the moon's complex and active environment. Exploring Titan's northern lakes is like embarking on a journey to an alien world that is both familiar and strange. The lakes and rivers, with their Earth-like features and hydrocarbon-based cycle, provide a unique opportunity to study a planetary body that is both similar to and different from our own. The mysteries of Titan's northern lakes continue to captivate scientists and space enthusiasts alike, driving our desire to explore and understand this enigmatic moon. As we continue to unravel the secrets of Titan's northern lakes, we gain not only a deeper understanding of this fascinating world, but also a broader perspective on the diversity and complexity of our solar system. The southern lakes, a puzzle of geology. Beneath the hazy, orange skies of Titan, Saturn's largest moon, lies a landscape that would seem both eerily familiar and utterly alien to any earthbound explorer. The southern lakes, scattered across the moon's surface, present a geological puzzle that has scientists scratching their heads. These bodies of liquid aren't filled with water, but rather a mix of methane and ethane, hydrocarbons that exist in a liquid state due to Titan's extremely cold temperatures. The largest of these southern lakes, Ontario Lacus, stretches across an area comparable to Lake Ontario on Earth, offering a stark reminder of the familiar amidst the alien. The geology of these southern lakes is a complex interplay of processes that differ significantly from those shaping Earth's water bodies. Unlike Earth's lakes, which are primarily fed by precipitation and groundwater, Titan's lakes are thought to be replenished by methane rain and fed by subsurface hydrocarbon reservoirs. The lake's shapes and distributions also differ from their terrestrial counterparts. Many of the southern lakes are clustered in a region known as the Lake District, a vast, flat plain dotted with numerous small lakes. This is reminiscent of Earth's prairie potholes, but on a much larger scale. The lakes vary in shape, from irregular, almost amoebic forms to more circular bodies, hinting at a complex interplay of geological processes. One of the most intriguing aspects of Titan's southern lakes is their apparent youthfulness. Earth's lakes often bear the scars of their geological age, with features like deltas, terraces, and sediment layers telling tales of their history. In contrast, Titan's lakes appear remarkably smooth and unblemished, suggesting they may be relatively young. This youthfulness is puzzling, as it implies that the lakes may be ephemeral features, perhaps filling and drying in a cycle driven by Titan's seasons or other, as yet unknown, processes. The lake's youthfulness also raises questions about the moon's geological activity. Are the lakes fed by active processes, such as cryovolcanism, or are they the remnants of a more active past? The southern lakes also present a puzzle in their composition. While the lakes are primarily filled with methane and ethane, recent studies have suggested that they may also contain other, more exotic compounds. These could include nitrogen-bearing organics, which could play a role in the moon's prebiotic chemistry. The lake's compositions are thought to vary seasonally, with changes in temperature and sunlight driving shifts in the balance of different hydrocarbons. This dynamic chemistry could have implications for our understanding of Titan's potential habitability, as well as its role in the broader Saturnian system. As we continue to explore this enigmatic moon, the southern lakes will undoubtedly remain a key focus of our investigations, offering a tantalizing glimpse into the complex interplay of geology, chemistry, and climate on an alien world. The rivers of Titan, carving paths in ice. Beneath the hazy, orange skies of Titan, Saturn's largest moon, a world of icy wonders unfolds. Rivers snake across the landscape, carving paths not through rock and sediment, but through ice. These rivers, filled with liquid methane and ethane, are reminiscent of Earth's waterways, yet they exist in an environment vastly different from our own. The temperatures on Titan hover around -290 degrees Fahrenheit, -179 degrees Celsius, making it the perfect place for these hydrocarbons to flow like water does on Earth. The rivers of Titan are part of a complex hydrological cycle, much like Earth's water cycle. Methane and ethane evaporate from the moon's lakes and seas, forming clouds that eventually precipitate back onto the surface. This process creates rivers that can stretch for hundreds of miles, cutting through the icy terrain. Some of these rivers empty into vast lakes, while others meander across the landscape, shaping the terrain in much the same way that rivers on Earth do. The largest of these rivers, known as Vid Flumina, is estimated to be about 250 miles long and flows into the second largest sea on Titan, Ligeia Mare. The landscapes carved by these rivers are alien, yet eerily familiar. The rivers wind through valleys and canyons, creating deltas and estuaries where they meet the seas. The banks of these rivers are lined with dunes of organic material, similar to the sand dunes found on Earth, but composed of different substances. The rivers themselves are not just channels for liquid, they are dynamic systems that transport sediments and shape the landscape over time. The erosion patterns and sediment deposits observed on Titan provide valuable insights into the geological processes at work on this distant moon. Exploring these rivers offers a glimpse into the potential for life beyond Earth. While the conditions on Titan are extreme by Earth standards, the presence of liquid and a complex chemical environment makes it a prime candidate for astrobiological study. The rivers of Titan, with their methane and ethane flows, could harbor unique forms of life adapted to these icy conditions. Understanding these rivers and their role in Titan's environment is a crucial step in unraveling the mysteries of this enigmatic moon and the broader possibilities of life in our solar system. The shorelines, a dance of erosion and deposition. Titan, Saturn's largest moon, is a world of alien landscapes that bear a striking resemblance to Earth, yet are utterly foreign. Its surface is adorned with lakes and rivers, but not of water. Instead, these features are filled with hydrocarbons like methane and ethane, which exist in liquid form due to Titan's frigid temperatures. The shorelines of these exotic bodies of liquid are a testament to the dynamic processes of erosion and deposition, much like those on Earth, but with a unique Titanian twist. Picture a familiar earthly scene, a gentle lake lapped by soft waves, its shores gradually eroded by the ceaseless dance of water against rock. Now, replace the water with liquid methane, the rocks with water ice, and the atmosphere with a thick, hazy soup of nitrogen and hydrocarbons. The result is a landscape both eerily familiar and profoundly alien. On Titan, the winds blow, driving waves across the hydrocarbon lakes. These waves, though smaller than Earth's, are persistent. Over time, they erode the shores, carving out features reminiscent of our own terrestrial coastlines. The eroded material is then deposited elsewhere, building up new landforms in a ceaseless cycle. The processes of erosion and deposition on Titan's shorelines are driven by a complex interplay of factors. The moon's dense atmosphere creates winds that can reach up to 50 km/h, more than enough to stir up waves in the liquid methane lakes. These waves, though gentle, are relentless, slowly wearing away at the shores. The eroded material, primarily water ice, is then transported and deposited elsewhere, often forming dunes or other landforms. This is similar to how sand is moved and deposited on Earth's shores, but with a crucial difference. On Titan, the sand is made of organic materials precipitated from the atmosphere. Titan's shorelines are also shaped by seasonal changes. As the moon orbits Saturn, its tilt causes seasons to shift, leading to changes in wind patterns and lake levels. During certain seasons, the lakes may swell, subsuming more of the shore and accelerating erosion. In other seasons, the lakes may recede, leaving behind new, eroded landscapes. This dynamic interplay of erosion and deposition creates a shoreline that is constantly in flux, a dance of geological processes that is both mesmerizing and informative. Studying these processes not only helps us understand Titan, but also provides insights into the broader workings of planetary geology. The dunes of Titan, a sea of organic sand. Titan, Saturn's largest moon, is a world of astonishing diversity, with lakes, rivers, and even dunes that bear a striking resemblance to those found on Earth, yet are utterly alien in composition. The dunes of Titan are a vast sea of organic sand, stretching across the moon's equatorial regions. These dunes are not composed of silicate grains like Earth's deserts, but are instead made of hydrocarbon particles, likely a mix of ice-coated sand and frozen carbon-based chemicals. The result is a landscape that looks eerily familiar, yet is entirely foreign, a testament to the incredible variety of geological processes that can shape a world. The dunes on Titan are massive, reaching heights of up to 300 feet and stretching for hundreds of miles. They are formed by Titan's winds, which blow predominantly from east to west. These winds carry the hydrocarbon particles, depositing them in vast, linear dunes that can be seen from space. The dunes cover about 13% of Titan's surface, an area roughly equivalent to the size of the United States. The particles that make up these dunes are thought to be a mix of complex organic molecules, possibly including polycyclic aromatic hydrocarbons, which are also found on Earth in soot and coal. The dunes are not static. They shift and change over time, shaped by the winds and the seasonal cycles of Titan. The landscape of Titan is a stark contrast to Earth's deserts. While Earth's dunes are often found in arid regions, Titan's dunes are located in a world where the average temperature is around -290 degrees Fahrenheit. The hydrocarbon particles that make up the dunes are frozen solid, yet they are still mobile, carried by the winds that sweep across the moon's surface. The dunes are not just a geological feature, they are also a crucial part of Titan's carbon cycle. The organic molecules that make up the dunes are thought to be a source of nutrients for potential life forms, if they exist on Titan. The dunes are also a record of Titan's past, preserving information about the moon's climate and geological history. Exploring the dunes of Titan is a challenge that future missions may one day undertake. The Cassini-Huygens mission provided a wealth of data about Titan's dunes, but many questions remain. For example, the exact composition of the dunes is still not fully understood. The dunes are thought to be a mix of different organic molecules, but the precise nature of these molecules is still a subject of ongoing research. Additionally, the processes that form and shape the dunes are not fully understood. The winds of Titan are thought to be the primary driver of dune formation, but other factors, such as seasonal changes and the moon's internal heat, may also play a role. Understanding these processes will be crucial for unraveling the mysteries of Titan and its place in the solar system. The polar regions, a realm of shadows. Beneath Saturn's pale glow, Titan's polar regions present a landscape that seems plucked from a dream of Earth's Arctic, yet alien in its details. Here, the sun is a distant, cold star, casting long, dramatic shadows that stretch across a terrain dotted with lakes and rivers. Unlike Earth's water bodies, these are filled with liquid hydrocarbons, primarily methane and ethane, which flow and evaporate in a cycle reminiscent of our own water cycle, but under vastly different conditions. The lakes, some as large as the Great Lakes on Earth, are surrounded by what appear to be wet, boggy areas, hinting at a complex interplay of geological and atmospheric processes. The rivers carve their paths through a landscape that is eerily familiar, yet undeniably foreign. They meander and branch out, much like Earth's rivers, but their banks are not lined with vegetation. Instead, They are bordered by dunes and plains, sculpted by winds and the occasional liquid flow. The rivers themselves are not teeming with life, but they are dynamic, their courses shifting over time, much like Earth's rivers during floods or droughts. The polar regions are also home to vast, dark areas that scientists believe could be wetlands, where liquid hydrocarbons might seep up from underground, creating a muddy, marshy terrain. The shadows cast by Titan's surface features are long and stark, accentuated by the low angle of the sun. This is because Titan's axial tilt is similar to Earth's, meaning it experiences seasons, but its distance from the sun and its thick, hazy atmosphere make the sunlight much dimmer. The polar regions are particularly shadowed, with some areas receiving little direct sunlight for extended periods. This creates a realm of perpetual twilight, where temperatures plummet and the landscape is shrouded in a mysterious, ethereal glow. The shadows dance and shift with the seasons, creating a dynamic, ever-changing environment that is both beautiful and harsh. Exploring these polar regions is like embarking on a journey to a world that is both familiar and alien. The lakes, rivers, and wetlands are a testament to the power of geological processes, even in the absence of life as we know it. The shadows, the cold, and the dim light create a sense of isolation and mystery, a realm that is both inviting and forbidding. It's a landscape that challenges our understanding of what a planetary surface can be, pushing the boundaries of our exploration and imagination. The subsurface ocean, a hidden treasure. Beneath the icy crust of Titan, Saturn's largest moon, lies a hidden treasure, a subsurface ocean of liquid water and ammonia. This alien sea is a stark contrast to Earth's water bodies, not only because of its composition, but also due to the extreme conditions under which it exists. The ocean is likely sandwiched between the moon's icy shell and a rocky core, subjected to immense pressure and frigid temperatures. Despite these harsh conditions, the ocean could harbor conditions suitable for life as we know it, making it a tantalizing target for astrobiologists. The subsurface ocean on Titan is thought to be in direct contact with the moon's rocky core, a scenario reminiscent of Earth's deep-sea hydrothermal vents. On our planet, these vents support diverse ecosystems teeming with life, fueled by chemosynthesis rather than sunlight. Similarly, Titan's subsurface ocean might also host unique forms of life, if any, that thrive in the absence of sunlight and in the presence of ammonia and other exotic chemicals. The interaction between the rocky core and the ocean could lead to the release of minerals and nutrients, creating a potential habitat for extremophiles. Exploring this hidden treasure is no easy task. The icy crust above the ocean is estimated to be tens to hundreds of kilometers thick, posing a significant challenge for any potential exploration mission. However, scientists are already brainstorming creative solutions. One proposed concept is a robotic submarine, or cryobot, that could melt its way through the ice using heat generated by a radioactive power source. Once it reaches the ocean, it could explore the alien sea, collecting data and searching for signs of life. Another idea is to use a lander equipped with a radar system to map the subsurface ocean and study its properties from above. These missions, while still in the conceptual phase, represent our best hope for unlocking the secrets of Titan's hidden ocean. The subsurface ocean on Titan is not just a scientific curiosity. It also has implications for our understanding of the solar system and the potential for life beyond Earth. If life is found in this alien sea, it would revolutionize our understanding of biology and the conditions under which life can arise. Moreover, studying Titan's ocean could provide insights into the early Earth and the origins of life on our own planet. The hidden treasure beneath Titan's icy crust is a reminder that the solar system is full of surprises and that the search for life beyond Earth is far from over. The potential for life, a haven for exotic biology. Titan, Saturn's largest moon, is a world that feels eerily familiar yet utterly alien. Its surface is a vast expanse of dunes and plains, not of sand, but of hydrocarbon grains. Rivers and lakes carve the landscape, not with water, but with methane and ethane. These liquids, which would be gases on Earth, flow freely on Titan's frigid surface, creating a landscape reminiscent of Earth's water bodies, but with a twist that's uniquely alien. The lakes, some as large as the Great Lakes on Earth, shimmer under the dim light of the distant sun, their surfaces occasionally disturbed by gentle waves driven by Titan's winds. The potential for life on Titan is a tantalizing prospect. Unlike Mars, where life would struggle to survive in the harsh, arid environment, Titan offers a wealth of organic compounds and a subsurface ocean of liquid water. These ingredients, combined with the energy provided by the sun and the tidal forces of Saturn, create a unique environment where life, as we don't yet know it, could potentially thrive. The lakes and rivers of methane and ethane could harbor exotic forms of life, perhaps based on different chemistries than those found on Earth. Scientists speculate about methanogenic life forms, which would breathe hydrogen and eat acetylene, producing methane as a waste product. Such life forms would be as alien to us as the Titanian landscape itself. Exploring Titan is like stepping into an alien world that's eerily similar to our own. The moon's thick atmosphere, rich in nitrogen, creates a pressure similar to Earth's, making it one of the few places in the solar system where humans could potentially walk without needing a pressurized suit. The landscapes, with their rivers, lakes, and dunes, invite comparisons to Earth, yet the presence of hydrocarbon liquids and the frigid temperatures remind us that this is a world unlike any other. The potential for life on Titan is not just a scientific question, but a journey into the unknown, a quest to discover if life can exist in forms and places we have not yet dared to imagine. The future of exploration, unraveling Titan's secrets. Titan, Saturn's largest moon, is a world that feels eerily familiar yet utterly alien. Its surface is a mosaic of dunes, lakes, and rivers, but unlike Earth's, these are composed of hydrocarbons like methane and ethane. The lakes, for instance, are filled with liquid methane, which cycles through the atmosphere and surface in a manner reminiscent of Earth's water cycle. The dunes, on the other hand, are made of organic compounds that rain down from the atmosphere, creating vast stretches of terrain that echo the sand seas of Namibia or the Arabian Peninsula. This alien landscape is shrouded in a thick, hazy atmosphere, making it one of the most Earth-like worlds in the solar system, yet utterly unlike anything we've ever seen. The future of exploration on Titan is poised to unravel many of its secrets. NASA's Dragonfly mission, set to launch in the near future, will send a robotic rotorcraft to explore Titan's surface. This drone-like vehicle will traverse the moon's landscape, studying its chemistry, geology, and potential habitability. The mission aims to investigate the moon's atmospheric and surface properties, as well as its subsurface ocean, which is believed to harbor liquid water and complex organic compounds. The data collected could provide insights into the origins of life on Earth and the potential for life elsewhere in the solar system. The mission's mobility and advanced instrumentation will allow scientists to study multiple sites, much like a geologist exploring different regions on Earth. One of the most intriguing aspects of Titan is its potential to host life. The moon's surface is rich in organic compounds, and its subsurface ocean could provide a stable environment for life to emerge. The Cassini-Huygens mission, which explored the Saturn system from 2004 to 2017, provided valuable data on Titan's atmosphere and surface. It revealed that Titan's atmosphere is rich in nitrogen and methane, with complex organic molecules forming in the upper atmosphere and raining down onto the surface. The Huygens probe, which landed on Titan in 2005, provided the first direct measurements of the moon's surface conditions, confirming the presence of liquid methane and complex organic compounds. These findings have sparked intense interest in Titan as a potential habitat for life. The exploration of Titan is not just about understanding a distant world, it's about understanding our own planet and our place in the universe. Titan's unique environment offers a natural laboratory for studying the chemical processes that led to the origin of life on Earth. By studying Titan, scientists can gain insights into the early Earth and the potential for life to arise in similar environments elsewhere in the galaxy. The future of exploration on Titan holds the promise of uncovering new discoveries that could reshape our understanding of life and the cosmos. As we continue to explore this enigmatic moon, We are not just unraveling Titan's secrets, we are also uncovering the secrets of our own origins. The challenges of exploration, a world of extremes. Titan, Saturn's largest moon, is a world of extremes, presenting a unique set of challenges for exploration. Its surface is a labyrinth of rivers, lakes, and seas, but unlike Earth's water bodies, these are filled with liquid methane and ethane, plunging temperatures to a bone-chilling minus 290 degrees Fahrenheit, minus 179 degrees Celsius. The atmosphere is a hazy, orange soup of nitrogen and hydrocarbons, with surface pressure 50% higher than Earth's. This alien landscape is both familiar and utterly foreign, akin to a frozen, petrochemical Earth, yet with conditions that push the limits of our technological understanding. Navigating Titan's surface is akin to traversing a vast, icy desert punctuated by oases of liquid hydrocarbons. The moon's lakes and rivers are scattered across its surface, with some stretching up to 250 miles, 400 kilometers, in diameter. However, their remote locations and extreme conditions make them difficult to study. The Cassini-Huygens mission, which provided most of our current knowledge about Titan, used a probe that descended through the moon's atmosphere and landed on its surface. The Huygens probe's images revealed a rocky, icy terrain with what appeared to be drainage channels and shorelines, hinting at a complex hydrological cycle. Yet, the extreme cold and the lack of sunlight make it challenging to power and operate robotic explorers for extended periods. The moon's thick atmosphere, while providing some protection from radiation, also poses challenges. It's filled with organic compounds that could potentially obscure our view of the surface. Moreover, the atmosphere's high pressure and low temperature create conditions that are difficult to replicate on Earth, making it tough to test and design equipment for Titan exploration. The extreme cold also means that any electronic equipment would need to be heavily insulated and heated, adding to the complexity and weight of the mission. Despite these challenges, Titan's unique environment makes it a prime target for exploration. Its hydrocarbon lakes and rivers could harbor exotic forms of life, and studying them could provide insights into the early Earth and the potential for life elsewhere in the universe. The moon's atmosphere and surface conditions also offer a natural laboratory for studying complex organic chemistry. However, exploring Titan requires innovative solutions and technologies that can withstand its extreme conditions. Future missions may involve advanced robotic explorers, possibly even airships or submarines, designed to navigate Titan's alien landscapes and unlock its secrets. The promise of Titan, a stepping stone to the outer solar system. Titan, Saturn's largest moon, is a world that feels eerily familiar yet utterly alien. Its surface is a vast expanse of dunes and lakes, not of sand and water, but of hydrocarbons and methane. Picture Earth's deserts, but instead of silicate sand, these dunes are composed of organic materials. Envision our polar regions, but instead of water ice, these lakes and rivers are filled with liquid methane and ethane. This alien landscape, with its Earth-like features, makes Titan a compelling destination for exploration and a potential stepping stone to the outer solar system. The moon's thick, nitrogen-rich atmosphere, which is even denser than Earth's, creates a surface pressure similar to what we experience at sea level. This atmosphere, combined with its Earth-like gravity, about 14% of Earth's, makes Titan an ideal candidate for future human exploration. The moon's resources, particularly its abundant water ice and hydrocarbons, could be harnessed to produce fuel and life-supporting materials. This would make Titan a crucial pit stop for missions venturing deeper into the outer solar system, much like how Earth's islands were used as waypoints during the Age of Exploration. Moreover, Titan's lakes and rivers offer a unique opportunity to study extraterrestrial hydrology. These bodies of liquid are not water but are instead filled with methane and ethane, which behave similarly to water under Titan's frigid conditions. This allows scientists to observe processes akin to Earth's water cycle, but with different chemicals and at much lower temperatures. The Huygens probe, which landed on Titan in 2005, provided valuable data about these alien landscapes, including images of what appeared to be riverbeds and shorelines. Future missions could build on this data, providing even more insights into this fascinating world. Titan's potential doesn't stop at its surface. Beneath its icy crust, scientists suspect there may be a subsurface ocean of liquid water, potentially harboring life. This makes Titan not just a stepping stone, but also a prime target in the search for extraterrestrial life. The moon's resources, its Earth-like features, and its potential for harboring life make it a compelling destination for future exploration. As we look to the future of space exploration, Titan stands out as a beacon, a world that promises to unlock the secrets of the outer solar system. As we wrap up our journey across Titan, Saturn's enigmatic moon, let's take a moment to soak in the sheer wonder of this alien world. Imagine standing on its shores, the orange haze of its atmosphere casting an eerie glow over landscapes that seem both familiar and utterly foreign. The lakes and rivers of liquid methane and ethane shimmer under the distant light of the sun, much like the tranquil waters of Earth's lakes, but with a composition that's uniquely Titan. The dunes of hydrocarbon grains stretch out like vast deserts, while the icy mountains rise high, reminiscent of our own terrestrial peaks. It's a place where the familiar meets the extraordinary, a world that challenges our understanding of what's possible. We've explored Titan's unique atmosphere, its lakes and rivers, and the intriguing possibility of life in such an environment. We've seen how its weather patterns and geological features mirror and diverge from those on Earth, offering us a glimpse into the diversity of our solar system. Titan is not just a moon, it's a world of its own, a place that invites us to push the boundaries of our exploration and imagination. As we leave Titan behind, we're left with a sense of awe and curiosity. What secrets lie beneath its surface? What stories do its rivers and lakes hold? The answers to these questions are still out there, waiting to be discovered. And who knows, perhaps one day, we'll set foot on this alien world, walking along its shores and gazing out at its methane seas. For now, we continue our journey across the cosmos, exploring the wonders of our solar system and beyond. If you've enjoyed this journey to Titan, stay tuned for our next adventure. We'll be diving into the mysteries of another fascinating world. So keep your curiosity alive and join us as we continue to explore the final frontier. Until then, keep looking up at the night sky and let your imagination soar among the stars.